Hello everyone, welcome back to another stream. I'm so excited. Okay. Um so in the last stream, I kind of didn't end it very well. Oopsies, my bad. Um okay. Uh we got we got a flat 3D array of things actually rendering. I mean, we've done it. 3D falling sand simulation, all done. So, yeah. I guess, the thing to do now, I guess, is, uh, I don't actually know. I guess we can make it so, like, different numbers or different types, and then based on the type is, like, the color. So, like, we could probably have something like, um, we could have like a vec3 colors array. This might just be something that's defined in here. I mean, later on, it might be nice to actually have this as something that's defined, because I want to make it so it's easy to add and make new particles. So being able to just have it dynamically do what it needs to do, and I don't have to really like go in here. Every time I add a type, I have to add, a color or something for it. But for now, let's just do 2, just for simplicity. Um, and that should be vec3 array 2, and then parentheses, and then I think all I need to do is vec3 and vec3. So we can get some color here. That should not be a semicolon, it should be a comma. We could do like 1.0 for now. I mean, like, what's a color to use? We do like 0 0.5, 0 0.3, 0 0.2. Why is it complaining? Okay. Maybe we can do like more of a bluish one. So we can do like 0 0.2, 0 0.3, and 0 0.7. I don't know. I'm just making. Basically, though, the number here would be the index into this, sort of. So instead of returning a bool, we were. Hmm. Um. I was thinking maybe instead of returning a bool, we could try to return like a color. Possibly even we could just do like a vec4. And basically what we do is vec4 the the alpha value can be our condition here, but the um colors val -1. If value is I feel like that's overcomplicating it though. Why don't we just return a vec3 of the color? Okay. This should be vec3. There we go. And basically to return false, we can do vec3 false. Let's do like none equals just vec3 0. Actually, it might be better if you just do -1. Because then we know. And then we, instead of returning false on these, we just return none. I know if statements and shaders are really bad, so later on I'll figure out a better way to do this. But, and then, let's see. We don't use any of that anymore. If get voxel, we'll just say .a equals -1.0 break. And actually what we can do is vec3 temp color equals get voxel and then map pose. Yeah. And then in that we can do this. And then if the color isn't anything, we break. If it is, then we do color equals map pose, or not map pose. I don't know what I'm thinking. There we go. Color doesn't exist, does it? So what we should do is vec3 color equals vec3 0.0 by default. And then, oh, we have a color here. Okay. How about we just comment that out? Okay, we don't get anything. Something is bugged out, probably. Oh, there's no A value. Right. We'll just do R. Okay. Temp color. Oh. Yeah, no shit. This is not. There we go. That's what we want. Okay. Yeah. This is really messed up. Okay. Get voxel, temp color. Jeez. Okay. Let's just make sure I'm live. I wanna pop out the chat. Always on top. Thank you. Because I want to be able to see the chat. Okay, we're still not getting anything, but I don't know. Vec3 color. Oh, this needs to be not. If it's not -1, then we break. But we also need to set the color. I mean, we could just do that. Okay, okay. Sort of. I mean, okay, okay, if there isn't a voxel there, we're still rendering a color now, which isn't what we want. We just don't want to. Basically, we're hitting a 0 color. Basically, that's not what we want. So we're still hitting. We're just hitting 0. So we want this and then the break. Okay. Not quite. But let's see what happens if I add a 2 somewhere. So we'll just do like these corners right here. And we should get a different color. Okay. 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 We gotta figure that out. Because basically what's happening is we're hitting a 0, but we're not continuing what we should be, is the problem. These are so hard to debug. Shaders. If get voxel, we hit something, which is this. If it's not -1, we do this. Otherwise, I guess this color needs to kind of be... Oh, that's a problem. Green is frozen. Well, but that doesn't make sense though, because we're... because we're returning a color, right? We need to do if val equals 0, return none. That's probably what... Yeah, there we go. Okay. I was thinking I need to do like a whole bunch of complicated stuff. That's pretty good. That's pretty good. The colors are not very great colors, but we got something. We got something. So that's all that matters right now. I mean, these are unnecessary calculations right now. Okay. This is not a very great line. Well, because the problem is I can't negatively index an array, and if I over-index it, because if I get rid of the over-indexing code, it'll repeat, and I guess disappear. That's not good. It doesn't disappear, but there's like obviously black. So, yeah, something's not quite right. So that's just preventing over or under indexing. So we could try to increase the size of this maybe. Let's do 4 by 4 by 4. So we just need 4 to the power of 3, which is 64. So we need an extra int. Oops. And then and because it's 4x4x4. Okay. Then we need to change this to 3x3. I'm gonna have to figure out how to make it so that we can have negative values. I guess we'll have to just have a data for every quadrant, and we've lost. Oh, I need another row on each of these. There we go. That should be right. Okay. Yes. Yes, we have particles. We have particles. Oh, it feels so good. All right, we got to figure out how to actually send data from the CPU. Basically just sends this kind of data. We must celebrate. All right, sorry about that. Trying to share my achievement on the Discord. Okay. That reminds me, I should get mGUI set up. That would be kind of helpful. That might be later though. Okay, so we can render a array of voxels pretty much, and we can pick their colors from an array of colors. I mean, that's pretty good in my opinion. Like, I'm so happy with that right now. Like, there's nothing better than just having a successful bit of code. Okay, so I guess now is actually time to send data to the GPU. Or do I try and actually clean? I guess I should probably actually try and clean up some of the code a little bit. All right, let's create a save point here. We have particles data rendering needs BG. There we go. Yeah. All right. Let's clean up the code. It would be nice to have transparency working. That might be a little complicated to get working with some of this, though, just because the way it's set up. Okay. So we have So resolution time, we do have mouse. We don't need sphere. I'll leave that actually. I should move all the constants up here. Let's see, max steps, max raise steps is kind of the new value. We'll do constants. We can do like 100. Maximum distance. We actually don't. I should probably add if checks for this. So let's do to do. Add if checks for this. If it goes too, I mean, that's pretty much the max raise steps, because otherwise distance will cancel it out before raise steps anyway. So I feel like this isn't really necessary. I mean, we're not even getting really that much lag. We're not getting lag anyway from this in the first place. It's like, it doesn't really matter. I mean, it doesn't, yeah. I'm sorry, I'm just going crazy. Surface distance, yeah. Let me add comments to these. The max, the number of raise steps to make. FOV, I'll do to do, add this, mouse sensitivity. I want to get rid of the mouse code for now because I kind of want to make it so the camera stuff is actually done on the CPU side. So I'm not sure if this is needed. We'll move these up. I'm gonna move these here. To do make these uniform arrays passed from the CPU. Alright, does this still run? No. What did I mess up? Okay, we don't use scene anymore. I should probably make the ray march function actually do the ray marching. Rotate 2D. How much different is that from this one? Returns a vec. So you pass in the value. I feel like this one kind of just makes more sense to do. name this get particle, and then return vec4. Make that a vec4. Colors can be vec4s. We can pretend this is sand, and then this one's more blue, so we can just pretend it's water. We'll just make it 0.5. And then when we add alpha, make it work, and we'll have alpha. I'm going to leave both rotate 2D functions for now. Okay. Range, array, index, range check. Get the value in the array. Something I should probably do as well. Then okay, anyways, I needed this. Just something someone sent to me because I'm gonna totally forget this, but this is how you index the 3D array. Alright, let's see. Make sure everything still runs. It does not. What did I mess up? Oh, because I named this get particle. Instead of get voxel, it's get particle. And then vec4, and then color can be a vec4. Or actually for now, nope, stop. It'll be a vec3, and we can just do RGB there. We will drop it at temp color. Don't know what all that does. Okay, we still don't get anything. What have I done wrong? I should really add error checking to my shader stuff. Alright, lovely old Chat GPT. Actually, you can start with OpenGL. I think I asked it how to do the shader thing, and it actually gave me like something that'll actually error check the shaders. Let's see, vertex fragment. Compile shader. Yeah. This might be a good idea to actually do this. Create shader program. I'm just gonna copy it and hope that it works. Because like I don't get any error. I don't know what's wrong with the shader right now. So it's triangle render. And we have compile shader. Read shader file. Okay. Read shader file. And that literally has no change, so we'll just add that back. Compile the shader and error check it, then create the shader program. And then instead of compile shader, it's the create shader program. And then where do we use that? And screw all that error checking. No, what are you doing? There we go. Oh, read shader file. There we go. And this is shaders slash vertex, and then shaders slash fragment. There we go. Okay, error compiling shader, max steps undeclared. Oh, is that, yeah. Loop condition must be scalar boolean, yeah, whatever, let's see. Okay. Compiling share, no function with the name scene. We'll just say 0.0 because this is just old code. Okay. So this is so much more helpful, actually. No, it's wrong. Max distance undeclared. Okay, you know what? For now, we will just comment that back in so it'll compile. Okay. Everything works. We're fine. We're fine. It still works. Do we still have a mouse in here? Yes. when you vec2 mouse divided by resolution.xy times 2.0 minus 0, and then instead of frag chord resolution, do we need to know mouse? And then instead of rotate 2D, we can do, instead of time, we can do negative mouse dot x, negative mouse dot x. Okay, yeah, that's fine. Yes. Okay. Then we just need to do this, but for YZ, and then mouse dot Y, and make sure I change these as well. I don't see. Yeah, and then m times equals mouse sensitivity. Did I get rid of sensitivity? Yes. Okay, const float mouse sensitivity equals 4.0. All right. Okay, that's probably too much. I kind of need a ground back. The way to do that is if c dot y is less than 0.0, then return a vec4 of some color like white. Yep, and now we have a ground back in existence. It's technically all just voxels. And actually, we could do if it's equal to 0. Actually, we probably want to do like -1. So then it's under 0. Yeah, so then there's actually like a side to it, I guess. Things are a little hard to kind of tell the difference, but you know. The thing with this though is that it's limited by our render distance. But this is pretty good. Again, basically this is just a like temporary way to kind of move around and kind of see what's going on. But something I can also do, let's make a const vec for axis particle vec for, and then these can just be like red, just like debug. So if c.x is equal to -1, return the axis particle. Let's see what happens. We should get basically a wall on the x-axis, yeah. So the thing to then limit is and c.z equals -1.0. So then it has no depth. Yeah. So now we just have a straight line, basically. That's our... Basically anything needs to be in between these. And then if c dot y, c dot z equals -1 and c dot z equals -1, return the axis particle. I hope those are the right dimensions. If not, then no. Okay, no, we're back to that. No, why is C? If, yeah, there we go. Okay. So we're probably being overwritten by the ground. We'll call this ground. This is so epic. Yeah, okay. So now we have a X and a Y. So nothing should pass to the other side, basically. Yep. That is pretty cool. And then we could even get like a different color in here. So I guess if we look up what colors are typically used for the X, Y, and Z axis. Just why not? So X is red. I don't want your example, actually. No, I don't really want your example. I just wanted the simple answer and you provide it. So X X axis will make this the red. This is the Y axis. This says it's typically green. I don't know why there's two semicolons. And then Z is if C dot Z equals -1. It'll be blue. I guess it needs to very interesting. Yeah, red is X. But like how? X is not supposed to be... Alright, hold on. Let us not do this with the camera for now. Okay. So this is actually the y-axis. So the x is -1 and the z, yeah, okay. So this is the y-axis. This is the x-axis. X-axis, y-axis, and then z-axis, which I need to fix in the moment. Okay, if the x is -1, I gotta think. My brain is dying. Okay, if x is -1 and the z is -1. So this is if c dot x is -1 and c dot y is -1, right? I mean, who knows? Okay, yeah. We got it. We got the axes. It would be nice if I could make the sign go away. And we can actually probably go up by 2. That'd be fine. Yeah, let's go. Okay. Oops. No. They just tell OBS to stop. Stop. No. What did I do? I did not do something good. Something bad happened. No, I'm still streaming. That's fine. Select. Okay, there we go. I accidentally clicked a button I didn't mean to click. We'll take a screenshot. Voxels displaying the axes. Let's go. And probably also bring the camera in a little bit closer. Maybe like 5. I feel like it's a little close actually. Maybe 8. Just a little close. Why did it open over here? Yes, let's go. We can also move it over on the x-axis by maybe 2 as well, just to get a little more of the side view. Yeah, there we go. That's what I'm talking about. Let's get a screenshot of that. Just for the walls. Okay, I guess it's maybe time to clean up the code a little. And the question is, what happens on the intersection here? It must be cool to actually see the rays. Should I get transparency working? I feel like I should try to get transparency working. I have so many Chrome windows open. Let's see. Yeah, I mean, it shouldn't be too hard. I'm gonna add this back in. So I'm gonna rotate around that base axis of this. So everything's gonna be a little weird. But yeah. I just have to remember Z is blue and X is red. Oh, my eyes. Okay. I guess I could try to get alpha working. It shouldn't be too difficult. Let me commit. Cleaned up shader. And added axis voxels. We'll commit, and then we also added shader air checking, and we'll go ahead and push all that. I mean, I feel like that's a big part of the reason I did like ray marching is because doing alpha is a lot easier because okay, the basic premise of that is if you hit a particle and its alpha value is less than 1, then you keep looping, but you keep blending the color every time. And we technically already get the color for what we hit. So we can then check. Basically, timcolor.a is something, okay, then don't break. So, I mean, that's really simple. It's just if timcolor.a is less than 1, well, actually, we can just do if it equals 1, or we could add some sort of like is greater than like 0.85 or something, like some sort of flexibility to that. But you can see now is blue particles are gone because we just step right through them. Because, yeah. So what we need to do is blend the color, basically. The thing is I need to only blend the color if I hit another voxel. So I need to know if I hit a and at least in terms of this code, I need to know if I've hit a voxel already, and now I'm continuing a loop because it's alpha value. And if so, if I'm still currently not hitting a voxel, then don't just set the color or blend it because there's nothing to blend it with. Although, I guess there's to blend it with the background, but if you keep blending it, it'll probably be dark. I guess I'm not sure actually. I mean, okay, let's make this a vec4 so we actually have like alpha enabled on that. And I would say actually if we just do color dot alpha, so like because the alpha will actually no, we'll do temp color alpha. Then we can do I guess if we get here, blend the color instead. But that's the problem. Okay, instead we just set the color and break. Oh, but if it hits another color, we'll do vec4 and then 1.0. All right, let's make sure this still runs. Okay. Yeah, we shouldn't see blue because technically we just basically skip over it. So I actually had some code somewhere. Where I figured out alpha blending. I just need to find it. But it is buried in the depths of some places. Okay. Basically, alpha blending. Wait, float alpha. We hit L. Blend the colors. How color? Oh, it's okay. That's the color. I see. This is gonna be a little complicated, but the basic idea is this. Well, the problem is if we hit something whose alpha is less, we can probably do like 95, more like 98. I mean, it could just be 1, but eh. Okay, so F alpha would be temp color dot alpha. Alpha would be like the end product alpha. So like color dot alpha. Powcol is temp color inverse alpha. I'd be surprised this even worked. Alpha is the color alpha. Okay, call undefined. Where? Oh. Okay, we still don't get our blue particles. Probably because of that. Okay, everything is incredibly dark. And I think things that have an alpha value make it so you can actually see right now. So that's not the ideal situation right now. Okay. Yeah, that's the problem because like everything that's dark basically if temp color dot alpha is less than 1, we want to blend, else we want to just set the color and break. And we should, okay. Is there even the faintest bit of our desired particles? No, because we just skip right through them. Okay. Let's see. Alpha F alpha is not set anything. So not temp, it's just color. Color dot alpha. And then alpha is basically F alpha, unless no, F alpha doesn't get set anywhere. So we do float F alpha equals color dot A. I guess because color dot A gets messed here. So if we do F alpha, color dot alpha, the temp color, the color dot alpha, the inverse alpha, alpha. This is just alpha. And then we just mix the alpha in, but we already... Imagine having anti-aliasing on this. I mean, technically, that would just be... If I made this like 10, things are gonna look very interesting. Oh, they're just gonna fade in and out of existence. It's the surface distance. Oh, interesting. I guess no matter what, these are gonna just... Oh, I guess we don't even use surface distance, actually. Maybe not in this. Okay, anyway. This is complicated here. Alright, let's do color is, let's just do it this way, since that's the way I have it on here. And then float alpha equals 0.0. Then in the for loop, how many times we're allowed to pass through something, right? So if a times, I'm not going to use that. Oh, race skip. I mean, we're already going to skip through the ray. We're just going to do another iteration, basically. Because this is what this does, it just steps it again. Check for color and then alpha. Invalid swizzle mask A. $176. Right. Okay, F alpha is alpha. Then, okay. We hit something basically, and then we set F alpha. Okay, this is basically we hit something. We hit something. Then, if the alpha, we set F alpha, and then we set alpha equal to mix some random ass numbers, told, what is it? Iterations, or, I guess it would be, yeah, we'll just do iteration, divided by max ray steps. And then if the color has an alpha $181, Right, I need to change these all to alpha. Okay. Still not... Something's not quite right. Um... I'm trying to think. I've made a huge mess here. Okay, we can just do big 4, all zeros. Get rid of this. We don't need that. Um, this is a disaster. Yeah, basically, this is back to how it's normally done. Um, okay, everything should work. Yes, except for blue not appearing. Okay, let's see. Data color to alpha. Color so far. I copied this because it's a little more clear. Okay, we hit something. Maybe instead of checking alpha, we just blend regardless. God damn it. The only thing we need to check is if temp color dot alpha is 1.0, then we break and we're done. Other than that, okay. So color so far is just color. Voxel color is my temp color. I don't know what data that colored alpha is. Voxel color, voxel color, voxel color. What is data that color.a? Oh, okay, we got transparency, but it's very bad when it goes into the void, the colorless void, because it doesn't have a color to blend to, basically. Or basically the ray is told to just go into the void. So we need a way, because basically the iterations goes all the way, but the color, so we kind of need to do, and color, actually we probably don't even need this anymore. Yeah, that's actually, oh, yeah, we do need that still, because, alright, so we're still, interesting. Alright, let's do this. If iteration, not iteration, iterations is less than max ray steps, then allow this. Otherwise, do nothing. Okay, that's a lot better. Now we don't have that weirdness. Yeah. We got transparency. Alright, let's see if I can get a screenshot. That's a really bad. I wish I could do. I'm used to doing Windows Shift S because when I'm on Windows. Okay. Transparency. Okay. Yeah. Let's see. I do want to say. All right. All right. Let me see if I can just disable mouse. The way I would disable mouse is just by saying vec2 0.0 there. Yeah. Alright, I feel like water could be a little more existent. Yeah, that's better. I guess the thing is later to figure out, maybe given different pixel types, like how to blend. So like water, like if you have multiple waters, the alpha is gonna stack up. But like if you just hit another water, maybe the alpha doesn't stack, so it's just the same blue color all the way through. I mean, that's one way. I need YouTube. Can you not share playlists on YouTube? So inconvenient. Very inconvenient. Sorry, I've been typing away at some Discord chats about programming and graphics. Oh, I hate calm. Okay. I really wish I had more viewers, to be honest. Right, Chrome, what's new? Don't need that. I have so many Chromes open. Okay. Chat GPT. We are freed from calm while using it. Okay. I have way too many Chromes open. I have 2 Chat GPTs open. Okay, that's a lot better. Alright, I guess we have alpha. Let me make the mouse work again. I really hate when I do that. So you can actually like look around. I managed to mess something up. Okay. Some reason. Alright, let's full screen. Look at that. Yeah, so this is what I'm talking about is like the waters, they like continue to add up and blend. And I mean, that's actually probably fine for if they're like not next to each other, but like if there's like waters like right a step next to each other, maybe the colors shouldn't blend. So we would want to probably keep track of like the last um particle type that we hit, and like if the last one that we hit um was the same type and there's the alpha happening, then we would want to not add to the blending. We would just skip per se, because yeah. So it looks really weird because it's just like blue. But yeah, that's pretty good. I mean, let's see. Uh, it kind of looks purplish. Yeah, that's so epic. That's so good. We got alpha. Okay, what are the changes? There's only one change, I guess. I need people to watch my stream. Alright, let's copy link. Yes, very inspiring. Look at the chat over here. Yes, very impressive indeed. I'm just talking to myself at this point. Okay. Uh, let's see. Okay, I guess the next thing to do is actually start sending data to the shader and yeah, I guess going from there. Yeah. So, I mean, the thing to figure out really is I don't know. I guess it would be nice to get a camera, like a fly camera in, like I had before. So like WASD movement and stuff. Basically, to do that, all I need to do is screw all of this math for the most part. Basically, I just need to actually pass in a world at least pass in like a transform, like a camera transform. I mean, ray pose is basically the camera position, and then the direction, all I have to do is rotate that by whatever. So really I just I don't know why camera direction is a 0.8. It's interesting. Is it just to like look up a little bit? Oh wow, what the heck? That's interesting to say. Changing a very small value completely destroys everything. Why would that be 0.8? Why can't it be like 1.0? Is that like the FOV? Like 0.6? Alright, let's get rid of mouse movement. We'll just do m equals vec2 0. Yeah. Be nice if I could run multiple. Okay. Try to remember that now. Yeah, that's definitely more like FOV. Well, it's not really FOV, it's just more like... Oh, not really FOV. I guess it's kind of FOV. Because if it's 0, then you just see literally everything, kind of thing. Interesting. Yeah, so I guess it would be really nice to get some camera position and rotation or something passed in as a uniform to the GPU, or just like a transform matrix or something. Let's see, screen pose. This is all a little more confusing. It's like a bunch of extra math, but it's like, why don't we just do what I had here? I guess it would be on Chrome. There's so many Chromes open. It would be just this. So ray direction is just normalize this as well. So if we just do vec 2 uv equals, and then I'll do new. What's this complaining about? Oh, there's not a parenthesis. And then ray direction, vec3 ray direction just equals what I had before. Does this break everything, or is this still basically the same? Yeah. So that makes kind of things easier, I guess. But yeah, so ray pose is basically the camera's position. Or ray pose is ray origin, so it is the camera position. So ray origin is just whatever camera position is. Ray direction is the direction that it should be facing, which we can already do probably with some graphics math. And actually, I'm probably just copy my mgui stuff over. Let's do that. But yeah, then camera direction and plane, all of that is not used now. Along with screen pose. So this is basically screen pose, mouse pose, ray direction and origin. Yeah. So ray direction is basically the direction you're facing, which is pretty easy. Yeah. Okay. Okay. Alright, I got pinged on Discord. Alright, make sure that still works. Fact does. And then mouse re-enable. I guess the next thing to do maybe is try to get mgui back in here and then kind of just control some of the stuff with that instead so that we're not like, you know, like I would probably not want to be able to rotate like that. Oh yeah, mgui in here would be great. I guess we'll do that. Let's get mgui in here. Well, I guess I need to probably clean up my code a little bit first, just to prevent it from getting too messy. Okay, shader stuff. And I mean, we could even try to color these better. Not really colored the best. But let's close these. And I guess maybe clean this up. So let's make a new, we'll just make a source file. We'll call it shader. And then we also want a header file. Okay. Add, and then here. These are all going to tabs. Might as well. Okay, shader H. Okay, let's see. Triangle render. We want to move these into there. Include /shaders.h, and then in shaders C++, we will include shaders.h, and then shaders.h we will probably okay. Triangle render will include OpenGL, or that'll be in the H. Hold on, I gotta rub my eye. Okay, remove that. We also need to include a string, and then we need these. C error comes from IOStream. Then and it'll probably give me errors. Oh, no, it actually just worked. Okay. Perfect. Okay, move shader load functions to their own file. Okay. So now instead of triangle system, we're going to create a new system called particle simulation system. We'll just call it particle system. Hashtag pragma once. And if we don't do that, then we derive from public system. We need to include // system each, and then public particle system and particle system destructor. Then we need to void init, override, void update, float dt, override, void render, override, void exit, override. And then private functions. Basically, we just need to copy all this into there. We don't. Let's see. Triangle render init. We can do. I guess we need to equals defaults. Equals defaults. And I show context. Generate definition. Generate definition. Generate definition. This needs to be render. Oh, this takes the GLFW window pointer window. That's right. Generate definition. We'll paste the init code so I can move render back to its acceptable position. Okay. Okay, we need triangle render H. We want the two private variables. Hashtag include dot dot slash shaders H. There we go. Which annoyingly also includes string, but yeah. We don't need that. Triangle render, just move that. And then move that all into here. We don't do anything here, but if dt is 0.0f, then return. We're getting error. Oh, we need. Yeah, okay. Probably not the best, just return and call it good, but yeah. Okay, load the contents of the shaders. Make sure they aren't empty. Load the create the shader program. Honestly, this can be just single liners. I mean, that's fine. Rendering code stuff. Update soon. Render. I guess I don't really need to clamp them. Okay, something. Oh, cause yeah, right. Then we need to go app. Or not app. We need to go to main. And so triangle render, we need particles system. Okay, now it should, yeah, okay. Perfect. Make sure there's no other code. Yeah, okay. So then these can be deleted. We'll make sure those get removed from here. Yes. Reload. All right, and we'll commit this. Move pixel simulation code to new files. Basically just cleaning up the code. All right. We actually have a pretty good thing going. I mean, I would call that pretty good. We could add other systems, but I don't know what kind of systems we would add. I feel like systems should get some sort of access to the app where it can like call app functions, be like, app get, get window or get system. Oh, that's what I should do. With systems, they should have a name. So like, um, std string. We will do import system name. Equals 0. Can I do like virtual? No, that's for functions only. But, particle system then is gonna plain default. Can I not access system name? System name, right. I need to figure out the constructors, basically. Power user. Hey, have you seen what I've got so far? I've got particles basically. None of this is CPU code still, like none of it except the code that sets up the shader. But I also got alpha working, as you can see with the little blue ones. I guess I should make these have alpha as well. But yeah, this is all just the fragment shaders, so this is all the pixel data. Basically, well, I mean, this is the voxel data. So if it's a 0, there's no voxel there. If it's a 1, there's a voxel there. And right now we just have a 64, well, 4 by 4 by 4 array, but it's flattened. But the 0 means nothing's there, and then 1 to basically the signed integer limit is what we have. But these basically, the number that it is there serves as the index into the colors. So if it's a 1, it'll index to here. It'll be 1 minus 1. So we'll actually index at 0 because 0 base indexing. But, 2 will be there. So basically, this is my like sand, quote quote, and this is my quote quote water. But I got alpha working. I guess something I might want to do is maybe something like this. So those axis voxels are not as painful. Oh wow, yeah, that's something I do need to fix. Is basically if a voxel that has alpha is right next to the same type voxel with alpha, it needs to not blend the colors. Otherwise, you'll get some pretty wacky stuff. But apart from that, I mean, it works. Okay, it works. They add, yeah. I basically need to make it so that it doesn't add if they're right next to each other, so you don't have like the weird faces thing. Only if they're the same type and they're next to each other. I mean, actually, that shouldn't be too hard of a fix. Now I really think about it, because this function's not used anymore. So they need to be like one big shape. No, that would be a huge pain. And okay, the thing with this ray marching is it's kind of interesting. If I take a sphere, right? If I use the old code that was in here, which is not here anymore, but basically if I had like an actual like legit sphere, it would turn it into voxels. But anyway, what I was saying is if I just keep track of the last like the last voxel type, I guess it would be color. If I keep track of the last color, and then if the next thing I hit, it has to be the next iteration, and it's the next thing I hit is the same color. Don't do anything. But if it's any more iterations than just one step over, then they're not next to each other, so obviously blend. I guess I just need to make like two variables to keep track of that then. I guess. I mean, int last. I guess we already have the current iteration. We already have track of the previous iteration, which I guess I don't think I moved that though. It might break something. Also, the weird thing is, if I remove this, you might see something very funky happening. Any guesses? Any guesses? The $1,000,000 question? I wish I could zoom in. That'd be great. But any guesses? $1,000,000 question. Just look at it a little bit. It's voxels. But why? Why, you may ask? Well, the thing that's really weird about this ray marching thing is basically it ray marches a voxel, basically. And for every space that it doesn't hit an actual voxel, it will continue the next step. So if I hit an actual voxel, it hits the voxel, now there's a voxel there. But if it keeps going until the end and there's no more iterations left in the loop, so it's never hit anything, basically the voxel that it steps is now there, so now it exists. So I don't actually know why it's black there. Oh, it's because the starting color. So if I make the background color white, you will see that this is what happens. Basically, you are trapped inside, and to prove that this is in fact just the step amount, if I make this like 10, it'll be way less. And it's very much based on position, as you can see. You make some neat graphics with not a lot of code. I know, right? But yeah, this is like painful. I don't know if 100's really. I feel like it might be too much, but that's what this does. Basically tells it, hey, you didn't actually hit anything, so don't actually do anything. So now background's white, but the problem with that is the blending is actually using this color. So actually what I could do to make the background white is do color equals vec for 1.0 here instead. There we go. So now we actually get our colors back. Although things that are transparent, oh, that's the red. I see. Things that are transparent kind of disappear fully, which I guess is because there's no actual white to blend upon. Like they're not actually blending upon that color. Yeah, but because the background color is black, it means that they will do that. Lighten only blend mode? I suppose. So, I mean, the world's gonna be technically black. Like, the background color is gonna be black anyway, so once other voxels are added, and I guess, like, adding like an actual background color would be something I just do when I like clear the pixels, I guess, or something. That's where things might get a little complicated, because the thing is, if I want to render other objects in the world that aren't ray marched, which I might want to in the later on, the problem is they'll all be behind just the entire this, because this is just a pixel shader. There's no depth buffering. So what I'd have to basically figure out how to make the depth buffer work with it kind of thing, and I don't think it's that hard. But I also haven't really looked. But anyways, this is just the alpha blending stuff. How many FPS are you at? I actually have no idea. I was actually just about to start putting mgui in. This seems to be running pretty smooth though, but there's also like not a lot going on. I was about to put mgui in though, and mgui has an FPS monitor. So I suppose if you stick around a little bit for me to get mgui in here, you can see. I was trying to add a naming thing to my systems, although mgui based for real. Although I think I'm just gonna revert all those changes. Yeah. Roll these back, leave the shaders though. Add alpha. Wow, I cannot spell alpha to axis voxels. Okay, mgui time. Mgui time. Let's pull up a Chrome window. mgui. All right, let's see. Dear mgui. Bloat free. Yeah, I'm sure of that. Actually, it runs pretty good. I like mgui, although I'm not entirely sure how to use most of it, like this stuff. I don't know how you would do. That's beyond me. But I think installing it. Basically, you just make like a whole game editor. Can you sudo apt install it? I mean, I guess, but I was gonna just add it into my project. Because the thing is, I want other people to be able to, like, pull the project and run it without having to install crap. It's just that, like, it has the stuff built other than OpenGL that is kind of left up to you on how you obtain it. Which I do have, I actually do have instructions in my README for that, but I think mgui is pretty much just drag and drop. Like, you just need to... Yeah. mgui is not really... mgui is just a, like, drop-in thing. So I think you do backends and then all the ones that are OpenGL ones need to be plopped in from here, and then I think all of this needs to be plopped in. I could be wrong. I guess it would help to figure out usage getting started. Copy paste each file. Compiling and linking. Decide which branch to pull the repository in a submodule of your project, or simply download and copy the repository and yours and commit it. Download and copy the repository and yours and commit it. Add the files to your project build system of your choice so they get compiled and linked into your app. All source files in the root file or folder, and then add selected from the backend's implementation files corresponding to the technology used from the mgui backends folder. If your engine uses multiple APIs, you may include multiple backends. Oh, interesting. Okay. Yeah, it's pretty much just drag and drop and then just include the files you need. So, Sea Lion, let's get a terminal open. Try. Git clone. Actually, let's make new mkdir. Thank you. I'm gonna head to bed now so I can wake up at a good hour, but good luck. Thank you, and good night, and sleep well. Have a good sleep. Okay. Make directory. I kind of lost my thought there. Oh, yeah, mgui. That's what we were doing. cd mgui. We should have an mgui folder now. Yeah. Okay. So I don't know why I'm doing. Okay. Git clone. Boing. Right. And it's all in mgui now. Load faster. Now that I think of it, there's gonna be an mgui folder in mgui. No. Okay. Let's delete. Let's try this again. We'll git clone here. Add mgui. I don't know if it works though. Oh, because the git folder, I see. Can I... I don't know. Okay. mgui should be in here, and then all we need to do... include mgui. Okay, so mgui's instructions. Compiling and linking. So everything in the mgui slash folder with this C, P, P, and H. Okay. So that would be, I don't know what I'm doing here. A lot of files. mgui slash imconfig h mgui slash mgui c++ and mgui slash mgui h mgui slash mgui demo mgui slash mgui draw mgui internal mgui tables mgui tables and then widgets imsdb rectpack and I am text edit I wonder if you're able to just like mgui slash you know whatever star.c++. Does that work? No. I wish. I wish. Okay. And then we need backends. GLFW. OpenGL. That's impl xxx. Slash backends. I'm gonna copy this. mgui implementation glfw and mgui backends mgui .h and then we probably also want OpenGL 3. Okay. Create the mgui context with the create context. Set configure, load font styles, setup style, initialize the platform and rendering backends. Perfect. OpenGL, WebGL, GFW, Metal. Okay. Yeah. So OpenGL. I'm gonna open this in another page or another site just so we don't need these then. Load that. Basically, we need to why do I have so many Chromes open? Too many Chromes open. Okay. Let's see. Okay. Add the includes. I guess we'll do this in app. So app, and we'll close all of these for now. mgui h cmake include directories, include directories, mgui. And that would mean I don't need all of that. Yeah. Okay. Include directories, mgui slash backends. I mean, that's going to include all of it, but then I don't have to type all this out and just everything is included as needed. Include mgui. Okay. So we have mgui. Okay. Okay, app constructor code init. Basically, set up mgui content, set up platform render backends. If using docking branch. Window. We'll set that. Okay. The start of your main loop. Your code calls glfw poll events. Why is poll events here then? Okay, so glfw new. So basically, this is before render. Do I do it clear frame? GLFW poll events, maybe that should be first. Start mgui frame. I mean, technically we want to do this after rendering that, but for now, after render, you call swap buffers. And then add to shutdown. App init. That would be the destructor. Destroy mgui. We need to actually we already shut down the systems here. Yeah, okay. We might want to do those in reverse and maybe do them in here instead. I don't know. Do we get mgui? No, we get a bunch of errors. Undefined referenced mgui debug check and debug layout. Why? We get a window. We get a window. And we get mGUI. Yeah. Okay. Damn. Excuse me. Okay. Interesting. If mGUI begin menu, or is it just begin? Stats, and then mGUI text of FPS percent 0.2f mGUI it we need to find out IO dot frame rate. Oh, need a semicolon. And we crashed. Do I need to call mGUI end? There we go. 60 FPS. Right. Okay, yeah. And we have mGUI. Alright, I guess I should probably try and actually get some, like, camera position thing going, which actually should be really easy, given the way that this stuff works. I can just set a new uniform. We can do GL uniform, 3f, and then GL get uniform location, and then shader program, the name, and we'll call this camera position. Then we pass in some values. So we'll just pass zeros for now. And then we just go into our shader, FPS display. This is probably gonna crash. No, okay, fine. Surprisingly. Then we just go up here to uniform of vector3. Did I copy that? Camera position. And we scroll down here, and then ray origin equals camera position instead of a vec3. Yeah. All right. Camera position all done. Interesting. Kind of wonder what happens there, because technically there are 3 different voxels there then. This is very confusing to orientate myself with, but yeah. Now all we need to do is get some WASD movement in here. Okay. Particle system. Yeah, it would be nice to... let's see. It would be nice to... Hold on. Something I want to do is turn this down a bit so it's not as sensitive. And then... technically, this would already then just be our look, although the look needs to be reversed. X-axis movement instead of negative X. Yeah, I mean, technically we already have now camera movement. I mean, we just need to lock the mouse position pretty much. Not the best, but for now, that would work. Okay. And then all we need to do is some sort of static int. Let's make a struct static int or float. It's probably not the best way to do it. Particle system. For now, I'm just going to add a float pose x pose Y, and pose Z, and they're all 0.0f by default. I don't know why that's, there you go. And then these can be pose X, pose Y, and pose Z. And then an update, we don't have DT yet, so we're just gonna pretend DT is some number. Can GLFW get input a key name? Is get key window. I'll just move it here for now since we already have the window. Window. What does this return? An int key. I guess we'll if key equals 1. So basically if I press W, nothing renders. Okay. Cool. So if key W then we're not going to care about look direction for now because I don't actually have the look direction stored on this, so it'll just be the axis for now. We'll do, I already forgot, pose X plus equals 0.5f. Okay, that's probably a bit too fast. Oh yeah, this rotates around. Interesting. Well, because this rotates the camera's look. I guess not when it should. And 0.5 is too much. This rotates around. Yeah, this is really weird. I guess the actual look direction, I need to... Oh. I'm just trying to think. The ray direction. The position's fine. The direction is not. You translate and then rotate. Whereas if you rotate and then translate. Oh, I see. Okay. You don't want to rotate the position. That's right. Me being silly. Okay. Then we can just copy this. And then if it's S, then we subtract equals, and 5 is probably too much. Probably do like 2. A and D. So A would be Y, and 2 it would be negative Y. Then if we do if the space, then we do Z plus equals 2, and if shift, we want left shift, and we minus equals 2. We're still not doing like look direction. Oh. Something has gone wrong. Oh, D needs to be Y, and this needs to be Z. Completely forgot to change those. Would explain a lot. Although why I go up and down. Oh, Z is depth, which is forward and back. Y is up and down. This is Z. Forward and back. This is X, left and right. Can't believe I'm messing all this up. Okay. There we go. Not the best of things in the world, and it's incredibly hard to use, and I need to the X needs to be, there we go. There we go. That way this actually makes sense. We're gonna make the sensitivity really high again. So like 4. That way I can actually like look around. Yeah. Very hard to use controls, but knowing that it's possible to actually move around the world now. It's just very complicated. All right, left and right. This is red. This is left and right here. Yeah. Very complicated to move around in this world right now. It might help to just stick to this and not actually look around too much. But yeah, we can actually like traverse our world here. And like, if we go forward, this is gonna go on forever. Until the end of time. It's so cool to see it all like pop in. And I guess this should actually be negative, considering that we actually want to do we want to look in the direction that we actually do. Instead of negative and y. Yeah. Yeah, that's a lot better. Now we actually look in the direction that our mouse moves. That feels a lot more natural. Ignore the mouse, basically. This is so hard to use. This S, W and S go along here. This is A, or yeah, A and D. And then up and down is easy as long as you don't get disoriented. Yeah, but if you go into a pixel, yeah. What happens if you go into a transparent one? Okay, let's go into, oh, you can actually see. I wonder if I can make it so that, like a pixel, like if you're inside pixels, that they'll turn transparent. So like, if this like the first iteration, just turn the alpha down on it. Where's the alpha? Where's the alpha value? Yeah. I mean, that's pretty good. dumbass camera. Okay, the question is, does this actually run on its own? Like, if I build this, would this actually run on its own without OpenGL stuff being installed? Is it like baked into it? Or do you still need OpenGL dev stuff installed? Because that's, I guess, probably not. Yeah, I mean, it's worth a test, I suppose. I mean, I have OpenGL stuff installed, though. I don't want to uninstall it. That wouldn't be very great. Yeah, I think I'm going to leave the stream off here. It is a little late. So make sure I have all my changes pushed. And yeah, I mean, I'm in rewrite 1 branch. But yeah, I think that'll be it for this stream. I hope you all enjoyed, and thanks for watching. I hope to see you in the next stream. Alright. Don't forget to like and subscribe, you know, the normal ritual. Stay tuned for another stream, maybe tomorrow, maybe today. I mean, technically, it is a new day, so we'll see. Yeah. Okay, I gotta figure out how to end the stream. Oh, here we go.